Welcome to lesson 2 of the module on interest rates, money, and exchange rates. In this video, we're going to be looking at the equilibrium of the money market. We've seen what determines money supply, what determines money demand. Now we're going to put them together. So here's first a way of representing money supply. Remember, money supply is controlled by the central banks. We're going to take it as given, and let's suppose the central bank decides to make the money supply equal to M0. And it's not going to look at interest rate to determine how much money it wants to supply. It's not like regular suppliers that they respond to interest rates or to the price in the market. It decides how much money it wants to supply in order to control the interest rate. And it needs to interact with the money demand curve in order to achieve its goal. So that's money supply represented by a vertical line. So the money supply here is independent of the interest rate prevailing in the market. And money demand curve, as we've seen before, is downward sloping. And as any other market, supply and demand interact to determine the equilibrium interest rate, I0. If the interest rate is initially at a higher position, let's say I1, in this situation, people would like to hold M1 as amount of money that they want to use for their transactions. The central bank is providing M0, and that additional money available to people is not something they want to hold, so they want to turn it into interest-bearing assets. They turn to bonds, they buy more bonds, and remember, when demand for bonds goes up, price of bonds go up, and interest rates drop. So automatically, if money supply is M0 and interest rate is not at I0, the interest rate moves towards I0 in order to equilibrate demand and supply for money. The money market can be also analyzed using algebraic equations rather than graphs. We've seen that money demand is equal to KPY divided by I, and money supply is given. We're going to call it MS. Setting money supply equal money demand determines I. In this equation, on the left-hand side, we have money supply. On the right-hand side, we have KPY over I. I is the interest rate, Y is real GDP, P is the price level. We can use GDP deflator for this purpose, and K is propensity to hold money. But we can use this equation to determine I if we have the values of the other variables, and also examine the impact of the other variables like Y on I if money supply is given, and vice versa. That relationship allows us to determine what happens if any of these variables changes and then another one is endogenous. Okay, let's first practice with this equation and with the graph by looking at what happens if money supply increases. Let's say we start with an equilibrium at interest rate I0, money supply is MS0, and then the central bank increases the money supply. Essentially, this means that it shifts the money supply curve to the right. Now, once this happens, let's say this is achieved by buying bonds. The central bank comes in, buys bonds, and leaves cash with the sellers of those bonds. That cash is going to get deposited in banks. Banks are going to lend a big fraction of that to others. The lent amount gets deposited somewhere in the economy and keeps generating money. So money supply goes up. When the Fed buys bonds, it raises the price of bonds and pushes interest rates down. In addition, the additional money that is created is going to start circulating in the economy, and people who receive that money may see that they don't need it, and therefore, if the interest rates remain high, they're going to try to buy bonds. That raises the price of bonds further, drops the interest rate, and until this process continues until the interest rate drops to I1 and equilibrium between money demand and money supply is established. So that's how the economy moves from one equilibrium to another when the money supply changes. Let's look at the same effect through algebraic lens. Suppose that money supply increases temporarily, and we want to see what happens in the short run. All the analysis that we've had so far looks at short run, meaning that in a very short order, in months, weeks, what happens. We're not talking about years. So we increase money supply for a while, temporarily, and we want to know what happens. Let's suppose that this increase is for 6 months, and after that, we go back to the old trend in money supply. So in this case, if we want to use algebraic forms, we start writing the money market equilibrium equation, which is MS equal to KP over MS equal to KPY over I, and then you can actually solve for I and get I in terms of KPY over MS. Now, this means that when money supply goes up, interest rate has to go down because money supply is in the denominator. We've seen this graphically. This is algebraic version of it, just reinforcing the idea. I also want to say that this has a consequence for the exchange rate. We've seen this in previous module, in the previous modules, that the exchange rate is determined by the interest parity condition, which depends on interest rates in home country and foreign country. If the interest parity condition says that 1 plus interest rate in foreign economy times the exchange rate, that's the number of foreign currency units you get per unit of domestic currency, is equal to 1 plus interest rate at home, meaning that keeping your money in domestic currency and earning interest in domestic currency, times expected exchange rate, which is how much foreign currency you can get for your money now, 1 plus interest at a future date. Now, in this situation, if domestic interest rates go down, you get less for your domestic currency if you keep it in domestic currency, and therefore, if the expected exchange rate does not change, the only thing that can happen here is that the spot exchange rate in the market is going to depreciate. Now, if later on money supply goes back to its old own trend, then the interest rate is going to rise back up, and the exchange rate also is going to be appreciating back up to its old level. Let's do another exercise here and examine. These are useful for understanding how money market responds to various factors, and it's going to come handy later on when we want to understand how income, interest rate, exchange rate, all are determined together. Suppose real income level goes up. So let's start with our initial money market equilibrium. Let's say interest rate is at I0 when money supply is M0. Let's keep money supply constant for now. And let's assume that real income of people in this economy go up. So when real income goes up, people want to hold more money, demand for money shifts to the right. We've seen this before. So once we are at a higher money demand level, higher income, and more money is demanded, now we have a new crossing point between money supply and money demand, which is at this higher point. Interest rates rises to I1, and we're going to be at a new equilibrium with higher interest rates. So when an economy recovers from a recession, for example, even if the central bank does not touch the money supply, interest rate automatically goes up. In fact, if the central bank wants to keep interest rate constant, it has to shift the money supply curve or increase the money supply in order to move interest rate back down to its old level. Let's examine the algebraic form of this analysis. Again, let's assume the increase in income is temporary. Long-run changes are more complicated because they affect expectations. I'm going to come back to them in a later video, and it's a long discussion in a later module. For now, let's assume the increase in income is temporary, only in the short run, and we're looking at what happens in the short run. So first we solve the money market equilibrium in terms of interest rate. Interest rate is equal to KPY divided by MS. Now if income goes up, interest rate goes up as well. It's pretty straightforward here. And using the interest parity condition, you can also see that when interest rates go up, that leads to an increase in the value of the domestic currency, because interest rates being higher, people want to hold more of the domestic currency, and therefore, if the expected exchange rate doesn't change, if the changes are not long run, that means that right now people would like to hold more domestic currency, and therefore they bid up its price. The exchange rate of the economy appreciates. Of course, later on, when the temporary increase in income changes and the income goes back to its old path, interest rates are also going to decline, and that's going to cause the exchange rate to go back to its old path as well. Now, with the knowledge that we've gained regarding how real income and interest rate are connected with each other, also the role that money supply plays in this, later on we're going to see what role price level plays in this. But for now, let's focus on the connection between real income and interest rates. We've seen that starting from a money market equilibrium and a given level of income. Here I'm putting the two graphs together. One is a graph of interest rate versus income, which I'm interested in developing that relationship, figuring out how it looks like. And on the right-hand side, the graph shows money demand equal money supply, the money market equilibrium. And now let's say let's say that we have our real income equal to Y0 and money supply is M0, and the income level Y0 has given rise to money demand curve MD0. Now, let's say income goes up, real income for whatever reason. Let's suppose it goes up parametrically for now. Later on, we're going to see that income itself is driven by other factors, but let's suppose it goes up somehow. If real income goes up, money demand goes up. We've seen that before. And money demand curve shifts up or shifts to the right, whichever way you want to describe it. But the end result we've seen is an increase in interest rate in the money market. So interest rate, rather than being at I0, is now going to go up to a higher level, I1. On the left-hand side graph, you can see that the interest rate rises together with income, the effect that we discussed before. Inversely, if income declines, interest rate also declines as long as money supply is constant. So an increase in income pushes up money demand curve and the interest rate, and vice versa. So if income declines, money demand shifts back down, and that means that interest rate goes down together with income. If one follows the locus of the points that represent combinations of interest rate and income on the left-hand side diagram, you can see that it's essentially a straight line going through the origin. This is a very important relationship in macroeconomics. It's known as the LM curve. The name is old, goes back to decades ago when this curve was called money demand equal money supply. L was representing money demand, M money supply, and it gradually became LM, representing the interest rate that equilibrates money demand and money supply given the level of income. For every given level of income, this LM curve tells us what interest rate would prevail in the money market given the money supply. In the economy, given price level, given money supply and other parameters, if real income goes up, demand for money goes up, and that pushes up interest rate. Conversely, if real income declines, interest rate also declines, and the point representing the combination of interest rate and income follows a path which we call LM curve. Notice that, as I said before, the LM curve goes through the origin. If income is zero, you don't need any money for transactions, so practically speaking, interest rate that you're willing to pay or for money is zero. Since this curve is very important in our analysis, we're going to look at how it shifts and moves in response to various factors. Algebraically, it can be represented based on the money market equation, money supply equal money demand. We've seen that we can solve for interest rate and make it equal to KPY over MS. Essentially, the linear relationship between real income and interest rate is what is represented by the LM curve.